Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Please raise your hand if you did not get red mark for the 20th. Awesome. Let's go ahead and take a look at our Bellwork questions today. We need to be able to write the equation of a line algebraically that contains 2 points, right, or that satisfies the given condition. So we're going to go ahead and generate the equation of a line containing 2 points, and one of those points is not the y-intercept, which is most often the case. Then my go-to form is point-slope form, right? That's the most efficient way to generate the equation of a line containing 2 points. So let's go ahead and state point-slope form with just letters. So what does point-slope form look like with just letters? Braden?
Y minus y sub 1 is equal to m times x minus x sub 1.
Absolutely. Where m is my slope, right? My slope rate of change number that we calculate from our old school Algebra 1 formula, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And then x sub 1 comma y sub 1 is any point on the line. All right, so let's go ahead and calculate our slope m. We'll use our 2 points and do y sub 2 minus y sub 1. Keep in mind that subtracting a negative is the same as adding a positive. All over x sub 2 minus x sub 1. It looks like we get 3 minus the negative 1 is 3 plus a positive 1 is 4. Negative 2 minus 4 is negative 6. And reducing my 4 over negative 6 gives me a negative 2/3. Please raise your hand if you already had negative 2/3 for the slope. Negative 2/3? Great! So we'll simply plug that in for m right here and rewrite my answer in slope-intercept form. So here we go. Y minus a negative 1 would be y plus 1 equals negative 2/3 times quantity x minus 4, if I chose to use that point. I could have chosen to use negative 2 comma 3, in which case my answer would be y minus 3 equals negative 2/3 times quantity x plus 2, right? Because we're subtracting, we have to watch our sign. Awesome. What questions do you guys have about our point-slope form? Point-slope form. Then let's go ahead and rearrange that so that it's in slope-intercept form. Be ready to share with the class slope-intercept form with letters when I call on you. So what does slope-intercept form look like just with letters? Heather? Thank you. Y equals mx plus b, where m is my same m for my point-slope form, my same rate of change for value, and then b is the y-intercept. That is the value of y where my line crosses the y-axis graphically, or the value of y when x equals 0, right, algebraically or graphically. Let's go ahead and rewrite our point-slope form then in slope-intercept form. I'll hang on to my y plus 1 on the left, but I'll distribute that negative 2/3 through the parentheses so that I can get rid of the parentheses, combine like terms, and make it look like y equals mx plus b. So let's do it. Negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 4 is plus 2/3 times 4. Let's see, that's going to look like 2/3 times 4. So that's going to be straight across 8/3. Is that right? 8/3. So negative 2/3 times negative 4 is positive, and then 2/3 times 4. So we'll go ahead and do a rewrite here. Straight across, 2 times 4 is 8. 3 times 1 is 3. And then I'm going to subtract over. I'm going to subtract over that 1. In order to combine like terms, 8/3 minus 1, I'm going to rewrite that 1 as thirds. So how many thirds is 1? 3/3. So I'm subtracting 3/3 from that. And I get y equals negative 2/3 x plus 8/3 minus 3/3 is going to be plus 5/3. So my final answer looks like y equals negative 2/3 x plus 5/3. Raise your hand if you got that. Anybody got all the way to the thirds? 5/3? Way to go with the fractions, you guys. That's awesome. What questions do you have about the first two? So what did we add? Well, we added something from our Unit 1 test reflection. So the advanced algebra team, after grading the Unit 1 tests, got together and talked about some common mistakes that were made regardless of which teacher you had, which day you had, A day versus B day. And one of the things that we ran into was our solving squaring functions, right? Our solving squaring functions like this. if we had that quantity there. So we encourage you to consider solving equations as a process of reasoning that undoes my forward evaluation steps, reverse and undo to get my solving steps. And so whether it was number 1 versus number 2, the answers are going to be very different. How come? Because my order of operations, when evaluating an expression that contains an x squared, is very different than my order of operations when evaluating an expression that includes an x plus 4 quantity squared, right? If we're going to solve for x in this first one, I'm going to add or subtract first to undo that addition, and then lastly, take the positive and negative square root. Versus here, I'm going to take the positive and negative square root first to undo that squaring and get that quantity x plus 4, right, alone, and then do my subtraction last. And so very different in terms of my strategy here. So if we were doing our forward steps and I were to plug in a value for the x, I would square it and then add 4. That's why my solving steps are subtract 4 and take the positive and negative square root, right? That's how we're going to generate our two solutions. So we'll subtract 4 first, minus 4, x squared equals 21, and then lastly we'll take the positive and negative square root, so x must equal positive square root of 21, and x must equal negative square root of 21. The good news is I saw this on several people's papers, so raise your hand if you had that. X equals positive negative square root of 21. Yes! How many solutions are there? 2! And this little exponent of 2 reminds me to be on the lookout for 2 different solutions. Awesome. Let's go ahead and do the second one then. What's different about the second one? Well, in my forward steps, if I were to cover up the equal sign and focus on the expression that contains my x variable, when plugging in a variable value for x, the first thing I would do this time is add 4 and then square it. So my solving steps are going to be very different. My first thing was plus 4 and then square it. My solving steps are going to be take the positive and negative square root first and then subtract 4 last. So my first step is to take the positive and negative square root. That's going to get my quantity x plus 4 alone. Sometimes I'll be able to reduce the number, right, the radical. Sometimes I won't. Either way, I'll be able to split it up into 2 separate things. This is where the arrows went to 2 paths on my very first activity on day 1, right? 2 paths. So one path is x plus 4 equals the positive square root of 25. In this case, that's 5. And one path is x plus 4 equals the negative square root of 25, and that's negative 5. You see the 2 different paths? Now we'll finish it out with our final solving step is subtract 4. So subtract 4 from both sides. I get x equals 5 minus 4 is 1, or x equals negative 5 minus 4 is negative 9. What? I don't believe it for a minute. Let's check that value, x equals negative 9 in my original. I can even use my forward steps. So negative 9 is the original, plus 4 is negative 5, and then square it. That means negative 5 times itself. Negative 5 times negative 5 is something. That's 25. And so even the negative solution here works. And I have, again, 2 solutions. It's just all the 2 solutions before it didn't reduce the radical. Positive root 21 and negative root 21. The solutions here, right, did reduce nicely. I got x equals 1 and x equals negative 9. What questions do you have about our squaring, undoing squaring? So when you create the radicals, when you're the one making the radicals to undo the squaring, that's when you need to include the positive and negative for the 2 solutions. All right. Lastly, a piecewise defined function was another area, and so on the bottom of the piecewise defined function was another area of concern, and so recall, we can sketch the graph of a piecewise defined function, right, by 1, knowing the equation, and 2, knowing the domain for which that equation applies. And so depending upon where you're looking, this graph will be given by a different function rule. It looks to me like whenever it's to the left of or equal to 3, the function rule is 2x plus 3. And so if I wanted to make the graph of 2x plus 3, I'd simply pick out my y-intercept, positive 3. My slope is a fraction, up 2 over 1, and get additional points. I can even count backwards. So the red line would be y equals 2x plus 3. However, this is only going to apply when I'm looking to the left of or equal to 3. And so this line will go forever to the left, but it'll stop right here with a filled in closed circle and an arrow forever to the left. Now, a different function gives the right piece. When I'm to the right of 3, but not including, then I'll do the blue function. The blue function has y-intercept -4 and rate of change down 1 over 3. Down 1 over 3. However, because it was a strictly, I know that I have an open circle there, So I've got filled in circle here, open circle here, and look, it's easy to see the two pieces of my graph based on the function definition. So we have two different pieces. How are you guys doing with number 3? Right, so we tried to combine our linear functions, that is sketching a graph, right, of a linear function by hand, and piecewise defined functions from last as a means of reviewing, right, our concepts that we've discussed thus far this year. Awesome. All right, let's go ahead and take care of our assignment number 5. There are no reading questions, so the maximum score for assignment number 5 is going to be out of 4 in Infinite Canvas. At this time, please make sure that your proper heading, name, first and last, 1A and number 5 are clearly labeled at the top right of your page. Give yourself credit in pencil for those you completed out of 26. Divide, enter, multiply by 4, and then round your Infinite Canvas score to the nearest half point, 0 to 4. There should be no 5 Infinite Canvas scores because this assignment did not include reading questions. Right? No more reading questions for Unit 2. What questions do you guys have about the Infinite Canvas score? So out of 26? Okay, then let's go ahead and put our pencils down, please. Our pencils, and now let's go ahead and grade with our grading pens. There's several slides to make sure that you're checking, please, as we move along. I'll be advancing the slides because I want to make sure we have adequate time to review our linear functions in Unit 2. So make sure you're checking with your grading pens. Move that out of the way a little bit here. And so I'll be advancing the slide. If you have multiple pages, please take this opportunity during check time to staple them together, to staple them on the side activity table. Go ahead and staple multiple pages together while you're waiting.
Did you actually drop the phone?
They might have deleted it. Let me check. Yeah, you can just ignore it. Which number was that?
12 and 14.
Oh yeah, they're deleted on the sheet.
Yeah.
It's just we did. Okay.
There's not.
I'm with you. Thank you. And we'll be advancing now. Yeah.
What's the for like that is greater than or equal to 1? How do you decide if it's 1 or 2?
So typically, right? Typically it's 2 if my subscript is a sub n and then a sub n minus 1. Here, the book chose to use a sub n plus 1 for the next term, and this is the current term. So then the first term would be the current term, and that's already known. Don't worry about the n greater than or equal to 1 or n greater than or equal to 2. It's just saying that the rule doesn't make sense unless you know the first one.
So we don't have to do that on the test?
You don't have to do the domain on the test. I'm going to be focusing on the rule. Does that make sense? Awesome. One more 3-6, and then we'll get to our 3-8 exercise solutions.
So we have to get the standard form and then
Depending upon the test directions, yes. Are you talking about for the homework?
yeah.
Yeah, that's fine. And 3-8 exercises. And so it'll be advancing, so make sure you're checking. We cut out 20 and 21.
So we shouldn't take points off for the end.
Correct. All right, ladies and gentlemen, as you're finishing up, go ahead and give yourself an accuracy of action out of how many you did, about how many did you get correct, please? Circle that in pen, and then make sure your infinite canvas score is boxed and pencil nice and big. Final check that your name's on there. If you have multiple pages, if you'd staple them together, using the stapler on the side activity table, I'd appreciate it. And then go ahead and pass them back to front. Front rowers, please make sure they're facing the same direction. During review time, we'll be able to enter these into the campus so that your grade is up to date as you go into your Unit 2 test next class. Thank you, front rowers. Everybody good? Number 5? Okay, ladies and gentlemen, I'll go ahead and pause the recording here so I can get your quizzes back. Thank you, ladies and gentlemen. So we want to make sure that we're comfortable stating the first several terms in a sequence, whether we're giving a recursive definition or an explicit definition. So everybody decide, is my first formula explicit or recursive? Is my second formula explicit or recursive? Go ahead and check with your partner, and then I'm calling you. So which of these is which? Okay, so which is which, right? Which is which? So what did you guys decide? Go ahead and tell the class when I'm calling you. Barrett and Logan?
We decided number one was recursive, the second one was explicit.
Absolutely. Raise your hand if you had the same thing. So the first one is recursive, second one is explicit. Recursive is convenient to list the first several terms because you get, well, the first one for free. In this case, a sub 1, the first term is -6. And you can just apply your addition or subtraction rule to that first term several times, or recursively, right? So -6 plus 2, -4. Plus 2, -2. Plus 2, 0, etc. So the first 4 terms of the sequence are easily gained if we're given a recursive definition. We can also get the first several terms, or any term for that matter, when given an explicit. If we're asked to find the 100th term, this would be a pain to use my recursive formula. But the explicit formula is easy to evaluate for a given term number regardless of what it may be, even if it's 1, 2, 3, and 4. But explicit really comes into its own when I wanted to find like the 75th term. I could just plug in the term number for n and evaluate like a function rule, right, for linear functions. So we'll go ahead and get a sub 1, the value of the first term by plugging in 1, my term number, everywhere I see an n. So that would be 7 minus 2 times 1. Right, 7 minus 2 times 1 is 5. A sub 2 would be 7 minus 2 times 2 is 7 minus 4 is 3. A sub 3 would be given by 7 minus 2 times 3, 6, 7 minus 6 is 1, and so on. So we can certainly use an explicit formula to generate the first 4, but I think recursive is quicker and easier. Not to say that this is hard, it's just that it's easier to use recursive. So last one, 7 minus 2 times 4 is 7 minus 8 is negative. What questions do you have about recursive versus explicit? Awesome. Let's take a look at the following sequence. What I want you to do is go ahead and then write a recursive formula with your partner and an explicit formula with your partner and be ready to share. So do both 1 and 2 for the sequence given by 23, 19, 15, 11, 7. Be ready to share your answer with the class. Look up above.
Yeah.
Yeah, No, it's A0. A0. So it's because this is A1, this is A0, so it goes in.
27.
Okay, ladies and gentlemen, some of you are still finishing up explicit, and that's okay. What I want to do is share your results, and so please be ready. Be ready to share with the whole class when I call on you. So what do you have for our recursive formula? Our recursive formula, what did you have for that? Marina?
A1 equals and AN equals A sub n minus 1.
So a sub 1 equals 23, and a sub n is given by a sub n minus 1 in the previous term, and then minus 4. Raise your hand if you have the same as Marina. That's absolutely right. Good job, and thank you for including the 2 parts. Nice job with the subscripts. An explicit formula is different. That gives me a function rule, right? A function rule that would yield any term by plugging in n, the term number, and working it out, right? And we've got a couple different forms for that. What did you have for yours? Katie?
I had 27 minus 4.
27 minus 4n. Raise your hand if you have the same one as Katie. So 27. Great, thanks. Is that 27? Is that 27 an actual member of the sequence, Casey? No, that's a 0th term. That's my ghost term that we could get by counting backwards, right? Counting backwards to a sub 0, right? And then my rate of change number d, my constant difference d, and that would give the general form. This looks like y equals a plus bx, and so this is a comfortable form so long as you can go and get that 0th term. Way to go, you guys. Did anybody do an alternate form for number 2? Anybody use the a sub 1? Dakota, what did you put? Awesome. So Dakota used the alternative form where we don't have to count backwards and find the ghost term, where we can just use the a sub 1 that was given, and then we just have to remember to do n minus 1 as my input instead of n straight up. Awesome. Either one is correct and you'll get full credit on the test, right? So long as it's correct, you can get full credit regardless of which of the 2 forms you choose. Which questions do you guys have on explicit versus recursive? So let's remind ourselves about some linear relationships. So at the first home football game on Friday, the South concession stand sold hot dogs for $2 and pizza slices for $3. Altogether, the concession stand made $1,266. 170 of that was from candy bars and 130 was from soda. Using that information, let's write a linear equation to represent the number of pizza slices, P, and hot dogs, H, that were sold. So we've got a lot of information here. We need to decipher what's important and what kind of linear equation we want to use to represent the information. So the concession stand sold hot dogs for $2 and pizza slices for $3. Altogether, the concession stand made $1,266, but 170 was from candy and 130 was from soda. Our task is to write a relationship for pizza slices P and hot dogs H. So let's go ahead and get rid of our unnecessary candy sales and soda sales. So if we had $1,266 for total revenue, if we took off our candy bars and we took off our soda, then we'd have the amount of money that was brought in solely from pizza slices and hot dogs. So let's go ahead and do that. 1, 2, 300. So is that 966? Is that 966? Great. 966 represents the revenue from pizza slices P and hot dogs H. So let's go ahead and write a formula then that's a linear equation that represents that. This is a perfect opportunity to use our linear combinations, right? When we have several things combined together towards some predetermined whole, then we're talking about a linear combination. In which form, point slope, slope intercept, or standard was most appropriate to model a linear combination? Heather? Standard, good. So we're after our AX plus BY equals C. This is where standard form really came into its own. So for every pizza slice P that we sell, that contributes how much money towards our revenue? For pizza slice. What was that? Do we know that one? Yeah, there's our 3. So 3P plus for every hot dog sold, that contributes $2. So 2H together is responsible for our pizza and hot dog revenue. So 3P plus 2H equals 966. Awesome. If 19 pizzas were sold, assume 8 slices per pizza, and all of the slices were sold, how many delicious hot dogs were sold? What? So if 19 pizzas were ordered for concessions, I get you, 8 slices per pizza, and all the slices were sold, then how many delicious hot dogs were sold? Great. So we're given how many slices were sold here. So we've got 19 pizzas times 8 slices of pie gives us 152 slices. Is that right, 152? So this is the same as plugging in 152 for P and solve for H. Let's go ahead and do that together. So I'll rewrite my relationship. 3 times P plus 2H equals 966. However, we'll substitute in our value of P as 152 slices, and that will allow us to solve for H. Let's go ahead and do that. So 3 times 150, so 150, 458, is that right, 458? 456?
456.
So 456 plus 2h equals 966. Go gadget arm, subtracting 456. I get 510, is that right? 510? 510? Awesome. Finish it out by division. So my final answer, I get h equals 255. And I can answer my word problem in words. It looks like 255 hot dogs were sold.
Yeah.
Awesome. Obviously, we'll do that in red. What questions do you have about our standard form for modeling linear combination situations? We're closer then, ladies and gentlemen. Let's go ahead and remind ourselves about finding x and y intercepts. Standard form not only models linear combination situations, it also provides an easy way to find x and y intercepts. So recall, to find the x-intercept of a graph when in standard form is easy. We'll simply plug in 0 for y and solve for x. If we were to plug in 0 for y and solve for x, the result is a Beatty equation. That y term will drop off in its entirety, and I get 2x equals 12. So what must x equal when y is 0? 6. Therefore, my x-intercept is 6, 0. Thank you for writing that as a point. Similarly, the y-intercept is the value of y when x equals 0. So if I were to plug in 0 for x and solve, we get the x term to drop out, and I'm left solving 3y equals 12. So what does y equal when x equals 0? 4. And so 0, 4 is my y-intercept. And we'll go ahead and plot our intercepts and connect them for a quick graph. That's pretty sweet. Go ahead and find the x and y intercept for number 2. Plot your intercepts and connect them carefully. Many of you borrowed a ruler, right? So you can make a nice sketch, and then just make sure you return the ruler at the end so that I can use them next hour. Thanks. Again, plugging 0 in for y and solving for x gives me the x-intercept. So the y term disappears, and I'm left with x equals 9 divided by 3 is 3. So 3, 0 is my x-intercept. Raise your hand if you had it. 3, 0 for x-intercept. 3, 0 for x-intercept. Good. Plugging in 0 for y gives us the x-intercept value. Conversely, plugging in 0 for x and solving for y gives me the y-intercept. So I get 9 divided by negative 4. So 9 over negative 4 is negative 9/4. And negative 9/4 is negative 1, 2 1/4. So negative 2 1/4. I can plot that. 0, negative 1, 2 1/4 is right here. Is that right? Is that what you guys got? And then I can connect them with the line tool. You guys can use your rulers. Pretty sweet. Pretty sweet. Recall that our special cases include equations, right? Equations where I only have an x or only have a y. Y equals negative 3 would be the collection of all points that have the same y coordinate. Y equals negative 3. If I considered some points on that line, they might include things like 0, negative 3. 4, negative 3, negative 1, negative 3. If I plotted all these points, what would it look like? Well, 0, negative 3, 4, negative 3, negative 1, negative 3. You guessed it, we have a horizontal line. A horizontal line, the slope of any horizontal line, that is the measure of how many units the line rises or falls as I move along from left to right. So your math woman, you can hop on here on your skateboard. It looks like it's rising or falling 0 units as you move along from left to right. In fact, the slope of all horizontal lines is 0. It does exist, but it equals 0. If I did a slope calculation, y2 minus y1, all over x sub 2 minus x sub 1, I'd get 0 divided by some number, like 7. 0 over 7 does exist, and it equals 0. That's different than a vertical line. A vertical line contains all the same x coordinates. So 2 comma 0, 2 comma 1, 2 comma negative 4. If I connect all these, I'd have a vertical line. If slope measures how much a line rises or falls as I move along from left to right, the definition falls short. I'm unable to move along a vertical line from left to right. Therefore, the slope is undefined. Undefined, and if I did a slope calculation, I would have gotten some number like negative 3 divided by 0. And we can't divide by 0. We can't have a 0 on the bottom of the fraction, and that's my algebraic indication that my slope definition falls short. The slope of a vertical line is undefined. All right, we're going to sketch a graph for each equation, and if we had to do slope-intercept form for one, x and y intercepts for another, right, which would we choose? Well, it looks to me like x and y intercepts are already picked out for 2. Slope-intercept form looks like it's already picked out for number 1, so let's go ahead and go that route. Slope-intercept form looks like y equals mx plus b. So to generate that, I'm going to subtract over the 2x. So 3y equals negative 2x plus 6. And we'll finish it out by a division. I'll divide each term by 3. Therefore, my final answer would be negative 2/3 x plus 6 divided by 3 is 2. Everybody, pick out the y-intercept and tell the class when I call on you. So if y equals negative 2/3 x plus 2, what's the y-intercept? What's the y-intercept? Olivia H? Is correct. So 0 comma 2, right, would be the value of the y-intercept as a point. And then my slope number as a fraction rise over run, Logan? Great. So from this point or any point, I could count down to and over 3 from left to right. Everybody do that. Down 2 over 3. Down 2 over 3. We can count backwards so long as we then went up 2 and then back from right to left. Connect those bad boys with our line tool and we're good to go. So slope-intercept form is useful because it allows us to make a sketch by hand easily. However, oftentimes it's easy to find the x or y-intercept simply by plugging in 0 for y and solving for x as we did before. So to find the x-intercept, we plug in 0 for y and solve for x. 6 divided by 4 is 6/4 or 3/2, 1.5 comma 0. To find the y-intercept, I'll plug in 0 for x and solve for y. 6 divided by 2 is 3, so 0 comma 3. And another easy sketch. Very nice. And one to go. What is the graph of x equals negative 4 going to look like visually? So go ahead and describe what x equals negative 4 is going to look like visually. Mark?
It's going to be a horizontal line.
A horizontal line? What kind of points would be on negative 4? X equals negative 4.
It'd be like negative 4 just has to be the first x, so we can put any number after that.
Good.
Like 1 or 2.
Let's plot those. Negative 4 comma 1, negative 4 comma 2, or negative 4 comma 3. If I connect those, what kind of line would I have? Straight up or down, right? Vertical line. So an x equals equation is a vertical line, straight up and down. Ooh. Awesome. Right? Does that make sense? So vertical line. And then what's the slope of this blue line that I've drawn? Go ahead and tell the class when I call on you. So what's the slope of this vertical line? Tyler?
Undefined.
Undefined. The vertical line slope does not exist. It's undefined. Good job. All right. So write the equation of the line shown. We could do that in slope-intercept form. If we were to pick out the slope number as a fraction, rise over run, by using our pen or pencil tip to count up and over, or down and over. And if we can see our y-intercept, then we don't have to do any calculations. So look at that. If y equals mx plus b, my slope looks like it's up 1 over 2, up 1 over 2, and my y-intercept is negative 3. Therefore, y equals 1/2 x minus 3. Go ahead and do the same for the next ones. Be ready to share with the class. Bless you. And what do we get for this red line? This red line, Aaron?
4 plus negative 3 over 2.
Raise your hand if you got 4 minus 3 halves x, or negative 3 halves x plus 4. Both are correct. Way to go, you guys. That's awesome. Our final thing today mixes up the colors. And so we try to do 1 in red labeled up there. 2 is this green horizontal line. 3 is the pink line through the origin. 4 is the blue line in the lower half of the graph. And then 5 is the vertical black line. Let's go ahead and get an equation for each of those. Be ready to share with the class on the smartboard. All right, so just go back, press right. So just use the pen tip and go right in the center of it. No, and then let go when you're done. Thank you, Kristen. All right, ladies and gentlemen, thanks for those of you who came up and shared your responses. I'm going to do a quick check, and then we'll have an opportunity for a stamp total for Unit 2, get you credit for your activity stamps and your Bellwork that you've earned throughout the unit. And then you're going to have some individual review and work time. So let's go ahead and take a quick look. Number 1 is the red line. Everybody look at top. Raise your hand if you had 5 minus 2/3 x, or negative 2/3 x plus 5. It's correct. Horizontal line in green, y equals 2. Raise your hand if you had number 2, y equals 2. Good job. The pink line through the origin, negative 1/3 x. The y-intercept was 0. Raise your hand if you had negative 1/3 x. Awesome. Number 4, 1/4 x minus 4. Raise your hand if you had number 4. The blue line in the bottom, and then a vertical line is x equals, every single x coordinate is negative 5. X equals negative 5 for number 5 is correct. Way to go. Thanks, hands down. What questions do you guys have about your linear equations? Excellent. Then you're going to have an opportunity to work and review with these concepts and these problems. But first, we're going to do a stamp check. And so at this time, we're going to give you about 5 minutes or so to go through and find all of your Bellwork red marks, day 1 through day 5. I'm sorry, day 1 through day 6, for a total of 6 red marks. Your activity stamps for a total of 12. So our first practice, 3-1 to 3-3, was out of 3. 3-4, 3-5 was our regression practice. That was out of 5. Our linear functions worksheet was out of 3. That was our bicycle problem and our pancake problem and our card appreciation problem. And then lastly, our sequences practice from last class with a single stamp at the end. Bring your total 5 plus 6 plus 1 is 12 blue activity stamps, 6 red Bellwork marks, for a total of 18. I'm going to go ahead and stop the recording now and save that.